We're going to talk about wastewater treatment. And, fun, we're going to go to the poop plant, right? Alright, we're going to see where the honey wagon goes with waste. What were the two main concerns with solid waste and treating solid waste at landfills? What were our two main concerns? Yes?
Was it the leachate, like getting the groundwater?
Okay, so that was one of the sanitary issues. So there were two pollutants that we were concerned about in sanitation. So one of the major concerns is sanitation. And you're absolutely right, leachate is one of the concerns of sanitation. What was the other major concern at the landfill? There's another major criteria. There's two main concerns of the landfill. Shanna? Recovery, yes. Recovery. Because we all know we live on a finite planet and we can't just keep throwing away stuff because there's going to be a limit to how much stuff we can throw away. We need to recover and recycle as many things as we possibly can. Okay, well, the two main concerns at the wastewater treatment plant are exactly the same. They're sanitation and recovery. So, let's just start with recovery. They are recovering three major things at the landfill, at the wastewater treatment plant. Three things. Can you think of one thing they're recovering at the wastewater treatment plant? Water. Yes, water. Trick question, right? Can you think of something else they're recovering at the wastewater treatment plant? We used to take this to the landfill, but in Fond du Lac at least, they're now taking it and they're applying it on the farm fields. What would that be? That would be basically the organic material that's left after the treatment process. It's now fertilizer, so they're recovering fertilizer. And they're recovering one more thing. Part of the treatment process at the wastewater treatment plant is anaerobic. You've got anaerobic decomposition. What gas are you having produced? Methane. So the other thing that they are recovering is methane. Okay? So these are the three major things that they're recovering. And we're going to see the process of how they do that. They are now using this methane, or they're going to be shortly using this methane to generate electricity at the landfill. And they're going to be meeting, I think, almost all their needs of electricity at the landfill with their own methane. Their electrical bill has been something like $30,000 a month. That's a lot of electricity. So when we're talking about why you should conserve water, why you shouldn't waste water, it's especially considering how much energy goes into treating that water at the wastewater end. So that's one of the major reasons to conserve water, is because of how much energy it takes to clean that water. And that's a key point of studying wastewater treatment. Okay, let's take a step back and just talk about sanitation. What are the pollutants in water that we're most concerned about? I'm looking for five major pollutants. Can you just name a pollutant? Hopefully the reading that you read will make you think of one. Yes?
I'm not sure.
MRSA, yes. Methanoxylin-resistant Staphylococcus aureus. MRSA, right? I don't require you to know what it stands for. All right, so pathogens. Present day, just a year ago, they were concerned, they were doing some studies, and they were finding superbugs in the water that are in the wastewater treatment plant water. And the concern is that these pathogens, these bacteria, are resistant to antibiotics. So it's very, very bad to have them released out in the environment and become more prevalent. So that was a major concern, and that's what that article was about. It was almost exactly a year ago that information came out. Are there any other pathogens you can think of that are in wastewater?
Yeah, so all the wastewater travels through pipes and it comes all the way here to this facility. 24/7 operation. The facility is staffed 8 hours a day for 5 days a week, and then Saturday and Sunday for 4 hours each day. So we are computer control. We have the state-of-the-art technology with SCADA, and plant runs very well. We meet effluent quality every month, month after month, so we're doing a very good job. As part of the tour, you'll see our new addition, which is biogas. It's a biogas project where we take the methane gas that we produce in the anaerobic digesters, we clean the gas, and then we run it in an engine, produce electricity, and put it back into the grid to save on our power costs. So, any questions at all? Okay, we're going to be taking out. Go ahead.
What do you mean by clean the gas?
We clean it. The gas is methane. It's a very raw form of what natural gas is. But it needs to be cleaned. We need to remove the hydrogen sulfide from it, and we need to remove the siloxanes from it. Siloxanes it's a byproduct of a lot of the soaps, cosmetics, lots of different products, hygiene products and whatever that we use every day, and it ends up in the gas, and it ends up as a fine powder in the gas. And if you just allow that to go into the engine, it'll destroy the engine because it's very abrasive. So we must remove it. Otherwise, there's a tremendous amount of wear on the engine very quickly. Okay? And in the process of doing that, what they do is they produce carbon dioxide, methane, and water. And they stabilize the solids, basically, so that the solids can end up going out on farmland. So there's about a 70-day detention time. There's 4 digesters here, and each one holds about 800,000 gallons. So it takes 72 days for what goes into the first digester to come out of the 4th digester. And it's in heat. Each digester has temperature. The first 2 are thermophilic. They're held at 131 degrees. The other 2 are meso. They're at 95 degrees. And if that fluctuation of temperature, if that temperature would fluctuate, the bacteria can die, or they can do some crazy things, and you don't get the digestion you need. You know, the digestion, how well we digest has to be documented with the DNR for spreading purposes on the farmland. Okay, so this equipment all has to work very well. The methane is used for 2 things. We use it for heating the buildings, and we also use it to make electricity. Behind me, inside that building, and we'll go in there later, there's an engine. And that engine's running on methane. Inside of these 2 digesters, you can see there's lids that move up and down. Well, that's a gas holder. There's gas underneath the lid. And we're taking that gas, running it through these cleaning units here. This is a hydrogen sulfide stripping unit. It's biological, and we remove the H2S, very corrosive gas. We remove that, and in these 2 cylinders, there is carbon. It's actually coconut shells burned, and it's a carbon source, and that removes the siloxanes. So the gas going into the engine is very clean. It's more like what natural gas is. And then that engine runs at a certain rate and produces about half of our overall power needs. Okay? Questions about that at all? Any excess gas that we do have, there's a flare. And you know what it does is it automatically, through pressure sensing devices and whatever, it opens it up, it automatically lights, and it burns off the excess gas. Okay? That's good to go back into the soil for the crops, because we spread, you know, our biosolids on several farms nearby here. This room, where we are now, is in a place in the solids handling facility where we take the biosolids out of the last digester and we dewater it further to get the water out of it again, so that it can be easily managed to go to the farm fields. The liquid in the digesters is about 2% solids, so it's very liquidy. We add a polymer to it. It's a white powder that's almost the consistency of sugar. We add water to the to that product to make a solution, And what that does is it takes the solids in the biosolids, and it causes the solids to release from the water, again separating it, so that we end up with about 25% solids. Or it's more like black dirt, and that's what we haul out to the fields. The water goes back into the plant for treatment. Now, why do we do that? We do it because of the number of truckloads, the amount of material we have to deal with every day. We pump 300,000 gallons through our centrifuges upstairs, and that's how we dewater the biosolids. We add polymer to our anaerobic digested sludge at the rate that's pumping over at the rate of about 350 gallons a minute, and then it's dewatered by spinning it in a centrifuge about 2,500 RPM. Follow me. We also put in 2 stainless steel silos, insulated, that can each hold 20,000 gallons of byproducts from cheese companies, whey or dairies. Whey, and there's a company in town called Milk Specialties that has a whey byproduct that's very strong, and BOD. Do you know what BOD is? No idea? Well, we can talk about that later. But anyways, very, very strong. I'm talking in the hundreds of thousands of parts per million of BOD. Now, you can't put that into a treatment plant because it won't treat very well. It's too much for the system. So we take it direct into those tanks, and then we feed it slowly into the digester. And what that does is it aids us to produce more methane. Okay, the cheese companies need to get rid of this product because it's a byproduct. They can't use it. Some of them have just spread it out on farm fields, but we're taking it from them now for free, and we're producing energy out of it. So that's about as green as it gets. So that was an addition to our project, and it's working out very nicely. That comes into this building, and there is what's called a wet well. The wastewater is continuously flowing into the plant every minute of every hour of every day. It never stops. And there are pumps down there that run automatically. They speed up and slow down in relation to the flow coming into the plant. This is the first and only time throughout the entire facility that the wastewater is pumped. So that wastewater is lifted some 60 feet up in the air into a box, and it travels down channels where it goes through a flow meter and preliminary treatment. Preliminary treatment is it's screened. Screenings, the debris that's in the wastewater, the garbage is removed, and then the grit or the sand is removed before it goes into the plant for treatment. So our average flow here is about 6 million gallons per day. But when it rains, the flow increases to up to as high as 50 to 60 million gallons per day. Any idea why that might be? Well, there's just the city of Fond du Lac alone has 200 miles of underground sewer. And those sewers have been underground for some of them up to 100 years. So over that time, there's cracks and things that happen to the sewers, and water, when it rains, seeps into those cracks and gets into the sewers, and it basically takes the groundwater in with that. Now, the city of Fond du Lac spends about $1.5 million every year on trying to fix those cracks and also replacing sewer throughout the community. But when you got 200 miles of sewer, that's a lot of sewer. All the wastewater that comes to the facility is pumped up into that box you saw in the room we were just in. Then it flows through this channel, and it's being measured right here. There's a flow meter in the channel that actually measures the rate at which the flow is going through here. So right now it's probably about 9-10 million gallons per day. We had some rain this past week, so the flows are up a little bit. Because we have a very flat area around here, so it needs to get pumped from area to area, so that if it can flow by gravity, it does, but there needs to be a number of pump stations to get it here. And those pump stations need to be maintained and working. Otherwise, the flow stops there, and it backs up into the home. Okay? Now this wastewater is being, everything that we do here is all being watched by computers and by operators and mechanics. We're all dealing with the equipment as well as the process. It's a belted screen that goes around like this and picks everything up. It brushes it off, it grinds it up, and it ends up in a dumpster downstairs, which I'll show you in a little bit. Okay, follow me. This is basically where it all goes. It goes out here, and then the flow splits, goes through 2 channels, and comes out at the primary clarifiers. Okay. Primary clarifiers meaning primary treatment. First, there's preliminary treatment, then there's primary treatment. Any questions? Yeah. This is where all that material collects, and then we take this out to the landfill, where what you'd have at other facilities because of the washing and of systems, and we got some of the state-of-the-art stuff, so that's a pretty good job. Might not seem that way, but if you're in the field, you really like the fact that there isn't the odors like there is at other places. The wastewater that goes through preliminary treatment, the screening through screen removal or screenings and also grit, comes over here, and then the primary sludge settles to the bottom of these clarifiers, okay? We got one to show you that's empty and not being used, and we got one that's in operation. These tanks hold about 800,000 gallons of liquid each, so there's detention time enough to settle out the primary sludge, and that sludge is also has the waste activated or secondary sludge in it because we co-thicken in these primary clarifiers. The solids all get scraped to the bottom, and then it's really thick and heavy, and we pump it over to the digesters. Right now we have about 100, between 100 and 120 cubic feet per minute of methane going into that engine. And it's producing, it's got a generator on it, it's producing electricity at about 400 to 450 kilowatts. It's about, be careful of the panels here, okay? Don't touch any of these levers or we'll knock the power down. So, this is a great project because we are producing this byproduct, so we're trying to make energy from it, and it's doing a superb job, especially when we get the waste from the cheese companies. That helps a lot. They produce a lot more waste, a lot more gas, I should say. On the other side of this generator here, this yellow generator, there's 2 green generators. And those are there for the purposes of losing power. Okay. This is secondary treatment. This is the activated sludge process. We have 3 tanks here, and they all hold about a total of 5.4 million gallons. This is aerobic, and there's aerobic microorganisms in these tanks that are feeding and breaking down the organic matter. They're also breaking down ammonia to nitrite to nitrate, and to stabilize the ammonia factor, because we have to remove about 95% of all the ammonia in the plant, okay, and the wastewater. So This is where most of the energy is consumed. This big pipe over here is air. We're pumping or blowing air into these tanks. Think of these tanks as being like an aquarium. In the bottom of the aquarium, you use a soapstone or whatever, and the air bubbles out of there. Well, we got about 6,000 diffusers in all these aeration tanks. And the diffusers, the air goes through the diffuser and leaves little bubbles coming to the surface, and then the bubbles come in contact with the bacteria, and they provide the oxygen that these aerobic bacteria require in order to keep alive and to stabilize and to keep in their life cycle. Okay? Any questions about that at all?
It might be a little unrelated, but how do you keep the waterfall from going in there?
They don't generally come in here, but they go in the clarifiers. They don't, I never see them in this tank. I don't know why, but they just don't. In the bottom of the aeration tank, there's 6,000 of these, roughly, okay? And this is just what the sheath looks like, but this is mounted on a rubber pod, and the air comes in through the bottom. And these little holes, you can hold it up to the light and you can't even see the holes. They're so fine. See how fine they are? They're really fine. And this is how the air goes out. If you just blew the air out in a big stream of air, you wouldn't have a very good contact of the oxygen to the bacteria. So you make the bubbles as fine as you possibly can and still have enough of a mix in the tank. So you keep everything suspended. That's the key. Okay? These are our blowers. We have 4 blowers here that represent about, in terms of cost, about $800,000. These were made in Finland, and they're unique to the industry because they're very quiet. They don't need any oil, and they're extremely efficient. They save us a lot of energy. And what these blowers are is a turbine. And they spin on a motor that's 322 horsepower. Like I said, this is where a majority of the power is consumed at the treatment plant, is in aeration for the activated sludge system. These turbines spin at the rate of about 19,000 RPM. That's sodium hypochlorite. This is like 10 times stronger than what you buy in the store as bleach, but it's a disinfectant. And we put it in our final effluent. We use our final effluent here within the facility to wash down equipment, wash down floors for our pump seals and whatever. So we use a lot of water. So instead of buying city water, we use the treated water. We add a little bit of chlorine to it to disinfect it to make it safe for the people working with it. So that's what's in the barrels. In the big tanks, we purchase aluminum sulfate. Aluminum sulfate is a metal salt, and the aluminum helps to precipitate out the phosphorus. Phosphorus is one of the parameters that we have to treat for at the facility. So we remove phosphorus. Sometimes we can remove it biologically, but we also add chemical to get it down to the levels we have to be at. Our limit right now is 1 part per million. Recently we received a new permit, and it'll take about 10 years to get there, but our new limit is going to be 0.04 parts per million, which means about a $20 million cost in today's figures of what it will cost to remove that phosphorus. So it's going to get to be real expensive here in Fond du Lac because we discharge to Lake Winnebago. So ferric chloride is being used to precipitate out phosphorus again in the sludge so that we don't form struvite. Struvite is it's a compound. It's magnesium, magnesium phosphate, and magnesium ammonium phosphate. And what it is a compound that plates out inside of pipes, almost like calcium does in water pipes, like mineral. Well, it's even plates out worse than that, and it'll plug up a pipe, even a big 4-inch pipe, in a matter of a few years. And if there's enough phosphorus and magnesium in the water, it can come out because of the digestion that we use. So we add a little bit of ferric chloride, and that helps to prevent the formation of struvite. Okay? All different treatment plants use different chemicals depending upon the nature for you. Okay? So these are the 4 clarifiers right here. Just follow me. We're going to go down to the UV area to show you what that looks like anyways. It isn't an operation, but you'll be able to see it. These systems were made in Canada, and there's about $1 million here too as well. So, okay, and it creates a fly problem because it's warm in here, and the flies tend to come out. They're in the water and they hatch and they come out in this room. So, this is a battle all summer long to keep the flies down. Okay, very good. Follow me. And pay their fair share, because each one of those parameters is looked at within the facility here as costing something. BOD, for example, BOD removal, the aeration tanks, and the anaerobic digesters are where a lot of that takes place. And there's lots of energy that's used at this facility, about $350,000 to $400,000 a year of electricity. We use over $300,000 of chemicals a year. We have between a $7 to $8 million a year budget. We have 18 people that work here. Those are just some of the basics. So we're going to go into the laboratory now, and we'll walk through and be able to see some of the things that are going on, some of the tests and whatever. But I don't know if the lab tech is here or not that usually talks to you, but if she's not, I'll explain some of the things that go on in the laboratory. And I have 3 sample cones set up. This is Autumn Fisher. She's a lab tech here at the wastewater plant, and she's going to explain to you what all happens here in the laboratory.
Everybody glad to be back inside. Well, as you said, obviously this is our lab. So this is where we perform most of our in-house QA and QC testing. There are some tests that we send out to a contract laboratory. They do all of our heavy metals testing. We have to monitor for things like cadmium, chromium, mercury, zinc, copper, all that fun stuff. But in-house, there are 4 main tests that we perform that are reportable to the DNR and part of our permit. So those include total phosphorus, total systemic solids, ammonia, and DODs. So each month we have a limit that we have to meet. If we exceed that limit, we can face fines and all.
The permit limit is 30 parts per million each day, but we're down into the 5 to 6 to 7 range, and that mainly. So it's considerably less than what we're allowed. This is the control room at the wastewater plant, and like I was telling you earlier, we control most of the equipment here at the plant through the computer system. We have several screens in our SCADA process, and the SCADA operator during his shift is monitoring and looking at all the screens, making sure everything is running like it's supposed to run, and then he calls and talks to operators out in the plant or in the collection system